We have it where they give us this graph of f and they ask us to determine the limit as x goes to -1 of f of x. So it's a little tricky because we have this composition of the function within itself. And the trick here is you want to see what's happening to first f of x as x gets closer to -1, and then use that. So then these values on the inside are going to be getting closer and closer to something. I don't know what yet. Let's just say getting closer and closer to something. You then want to evaluate what f of those values is getting closer and closer to. So let's see what I mean. So as x gets closer and closer to -1, f of x, this inner f of x, is getting closer and closer to 2 from both directions. So as I get closer and closer to -1 from the left, I get closer and closer to 2. And as I get closer and closer to -1 from the right, I get closer and closer to 2. Now, as I get closer and closer from the left, I'm getting closer and closer to 2, but from beneath 2. So as I get closer and closer to -1, right, I'm getting closer and closer to 2, but these values are staying beneath 2. And the same is true as I get closer and closer to -1 from the right. So these values over here, if we look, right? So now I'm over here, right? I'm picking values to the left, to the right of -1. So these are to the right. And again, these values all here are beneath 2. So that means that these values from both sides are going 1.9, 1.99, and they're both from both sides getting closer and closer to 2, but the key here is from beneath 2. So now these values right over here are going 1.9, 1.99, 1.99, 1.999, 1.99, again closer and closer to 2, but only from beneath 2, only from the left of 2. So now these values take on like x values when I evaluate f of those values. So this is like 1.99 or 1.9 right here. Right? If I go up, it's somewhere over here, and then I'm going to do 1.99, and I'm going to be up here. Then I'm going to do 1.99, and I'm going to be up here. And then I'm going to do 1.99, and then I'll keep going. And as you see, I'm getting closer and closer to 5. And that is the correct answer, 5. Now what was key is that from both sides from which I approached -1, I was approaching 2 from below 2. So if I'm going to draw another example for a possibility for f to illustrate how this changes. So let's look at how this changes here. So let's do another example. Let's say, so in this example, in this case, we have it that the answer is just 5. And that's because I'm coming to, as I get closer and closer to -1, these values of f of x get closer and closer to 2 from beneath 2. But now let's say I said that f looks something like this. Let's imagine f looking like this instead. Okay, so now I just constructed my own example. Don't think that this piece now is completely irrelevant. Okay, and all I care about is this pink piece. And let's evaluate the same question and see what answer we come to now. So again, this is my own example. If let's say I have, right, limit as x goes to -1 of f of x. Let's look at what's happening as I approach -1 from this side. So as I approach -1 from the left, I get closer and closer to 2. But I get closer and closer to 2 from beneath 2. So these values are like 1.9, 1.99, and so forth and so forth. And this is if I approach -1 from the left. Okay, and now let's approach -1 from the right. If I approach -1 from the right, I am getting closer and closer to 2 again. But this time they're from above 2, so it's like 2.1, 2.01, 2.001, and so forth and so forth, 2.0001. Okay, now if I look, right, now that means that these values, right, these inner values, if I approach from the left, are going to be going towards 2 from the left. So I'm going to be getting closer and closer to 2 along here. So if I look up, right, this is my pink graph, right, I'm going to be getting closer and closer to 5 as I approach -1 from the left. And then if I approach -1 from the right, these inner values are going to be above 2. They're going to be getting closer and closer to 2, but from above 2. So that's from this direction. And now I have to use this piece. And these values, as I get closer and closer to 2 from this side, I'm going to be getting closer and closer to 2 along y. And then that would mean that this limit, as I approach -1 from the left, approaches 5. But as I approach -1 from the right, it's going to approach 2. And that would mean that the limit would not exist in that case. So just go through these cases, and you could do another case where maybe this approaches it from, from the top in both ways, in which case the limit would exist. But go through it in all the cases. There's technically one other case where it exists and one other case where it doesn't exist. You could approach 2 from above, and then this one goes below or something like that, but not really